It's really high level. I'll try to, or really detailed. I'll try to explain it, but this is like what I work on.
So let me ask this, because I heard a really neat story on Risky Business this past week. I'm not sure how old it was, but it was talking about a bank doing, or a financial institution doing supply chain validation. And they started off just weighing the devices, and this is card readers, and like point of sale card readers. They started out just weighing them to see, like, within a micron, to see if they had added any chips to the board. Well, they got wise. The people that were adding chips got wise to that act and started carving some plastic on the inside of the housing before they sealed it. And once it's sealed, you can't open it again without breaking the tamper seal and making it evident. So to get around that, they made this like centrifuge thing that they mounted the card reader on, and something about the angular momentum of the stock one that was right.
You're changing your
would change.
Moment of inertia.
Right. And they could detect that and tell that the thing had been modified and it wasn't stock. Is it like that?
Yeah, except for it uses things that I'm good at instead of physics.
Sure. Right.
Yeah. It's like that. It's like that. It uses math to figure out whether hardware has been changed. So this paper stems from the SuperMicro rumors that crashed the stock. So I had been working on this a month before that happened.
Still hasn't recovered, right?
Nope. But yeah. I have a bunch of SuperMicro stock.
Because it will.
Because it will recover eventually, because we all know that that was all fake. So a little bit about myself. I went to school here at USC, graduated, worked as a software developer at T-Cube, which used to be in this building. Our company got bought by Capgemini. They axed our entire research and development group and at the time I was working on IoT and blockchain like technologies for insurance companies. Then I went to work as a contractor for the Department of Energy as a chemical engineer, which is what my degree is in. And then halfway through working through that, I decided I hated chemical engineering. Big waste of 4 years. Switched to cybersecurity because we had such a shortage of people that they were willing to take me, just because I knew like a couple coding languages. Now I work in cybersecurity, doing a bunch of cool stuff. This paper is like some sort of supply chain interdiction paper that I wrote, and it's going into the SAM trading room eventually after it goes through like a very extensive process. Because that's who I'm doing my master's with. But basically, the problem is that in the theoretical SuperMicro hack, they placed a small microchip on a motherboard, and that microchip did one thing, and that was detect that it was in a server, then open up a remote command and control connection to a remote IP. Now, this could have been detected via network egress filtering, and I don't know how major tech companies wouldn't be doing that anyway, but since the whole hack is fake, we have to go off of what would have theoretically existed. But it is a big problem. The US government cares a lot about protecting the supply chain. Working for the government, there are vendors you can't use. Everything has to be produced by a US company. It can't be produced. There's 47 like sensitive countries on the sensitive country list. If anything comes out of those countries, it's not allowed. So, for example, I am currently looking for scanning, networking, and mapping IDSs for level 0, level 1, level 2 communications. So like PLC, microcontroller, serial communication. There's a company called Indigi that supposedly is producing a mapping or scanning network that scans all the way down to like electricity on the wire. I don't know how it works, but it's made by 3 Israeli Defense Force agents. So we can't use it because it breaks our rules. As a government contractor, we're not allowed to use things that were produced by foreign entities. So supply chain is a really big deal. And on top of that, it's hard to vet supply chains. Constantly, we figure out that things are not what they seem, like Kaspersky or Acronis. Both of these things apparently have ties to the FSB, so not allowed to use them anymore. So we have to do detailed research. And then, one company sells itself to a subsidiary in Germany, which happens to be owned by, oligarchs in Russia. And now we're not allowed to use that software anymore. So we have to come up with something new. So that's like a large issue.
Wait a minute. The levels you were talking about, where do those come from?
OSI model. So 0 to 1, right? So 3 is your regular networking on workstation to switch. Your sort of IP TCP traffic. It's going to be level 3. Level 2 datagram and level 1 physical are going to be your more serial communication, and that's what communicates to PLCs or programmable logic controllers in SCADA systems. And then those connect to sensors, which is quote unquote level 0, level 1.
The level 0 is what threw me because I'm
yeah, it's like a new coin term because it goes past PLCs.
Yeah, that's you guys wandered out of my networking model and now you're all confused.
Okay,
you should have stayed in the networking
model.
Well,
so level 0 basically says so PLCs are hooked up to switches and actuators.
Yep.
And thermocouples, and those present very specific data values that are like electricity across the wire, and that's it. It's copper, and that can be messed with. For example, I don't know who did cybersecurity back during XP days, but like XP was super easy to hack because you just logged on and made your own credentials when you logged on, and it's very easy. And then things got harder going into like 2003, and then Windows 7 and Windows 10. But things actually have regressed back to those XP days and 98 days because PLCs and SCADA systems don't have authentication. Like PLCs don't have enough memory or RAM on them to do security. So you can, if you're on the network, you can send a command to a PLC and it can't authenticate who it came from. So it just accepts it automatically because they're built to do things. They're built to act. That's all they do. So
it's not that these systems were like magically more secure in the XP days. They just weren't on the network.
They're still not, supposedly not in the network, but people have gotten really good at jumping air gaps. So people have gotten really good at jumping air gaps, and there's 0 authentication on the network. If you were able to like walk up and plug into a switch on an ICS network, you would own the entire network. Just switches are unmanaged, PLCs can't authenticate who you are, so everything has to be done in the third, like on the network, because everything has to be done in the backplane. It has to be added on. It has to be a third-party application that goes on the back of the PLC, goes on the network, goes on the switches. It's the only way to secure ICS networks because no company wants to replace the equipment that they're using. I mean, most of that equipment's from the 60s, and it still works. So, entire industrial control systems for factories are tens of millions of dollars, and I don't plan on replacing it until it literally breaks. So security has to be done in the aftermarket. It's pretty much what I'm saying. This paper basically just talks about the why the government needs to do supply chain controls. It's been talked about. There's several acts that dictate how items are used in government agencies. Software and hardware go through 2 different sort of counterintelligence, where they sort of do research on the company and then do research on its supply chain. But it's really hard to get into the nitty-gritty of someone's supply chain because vendors don't want to cooperate with you. Vendors don't want to tell you who they subcontract to, who they are a vendor to. I always say, my idea is it worse to outsource to a company that's in your same country, or is it worse to go to another part of your company that's overseas? Because 92% of all computer parts are made in China, and the Chinese government has basically broad sweeping influence over the companies that exist in it. I mean, they already have dozens or hundreds of state-owned companies that masquerade as legitimate companies. And then, like half of all APTs are from China. But yeah, here's the chart showing you 90.6. But that was back in 2011, so you can imagine what it is now.
Where does that number come from?
It comes from a 6. It comes from an Atlantic article. Trying to get to the where's my beautiful pictures? It's all fluff.
The white paper fluff dance.
Here we go. So microprocessors, which are what they're going to use, which is what is used to, embed something. Microchips are made out of silicon, and silica has a very specific atomic structure. If anyone knows anything about Moore's law, we've basically been jamming as many transistors onto a silica wafer as possible, and we've gotten down to a really very particular architecture where it's a couple atoms gathered together that makes a transistor gate. And the idea is that you can scan down to close to that atomic level, and then identify transistors in a row on it, and then identify a microprocessor, and then basically take that, pump it into your machine learning algorithm, and run it by a baseline that you have from the vendor that says like, this is good, this is not good, this is good, this is not good. Because you take the standard commercial motherboard and look at it, it has about 15 microcontrollers on it. You have the main processor, and then you have all these tiny microcontrollers that control your SATA ports, your PCI ports, your USB ports, your LED switches. They're all very small. And then somewhere on the board hiding is an even smaller grain of rice, microchip that they inserted into your motherboard somewhere. But it's still going to have the same silica architecture because we haven't figured out how to make good processors without making them of silica. This is a three-dimensional atomic map of a microprocessor, and this is actually individual gates. This is two. This line is 2 micrometers. So, looking a single grain of rice is about 5 millimeters. So this is going to be 50,000 times more accurate, or more optics than a single grain of rice, so you'd easily be able to catch it. This particular one is used. These are all X-ray techniques because X-rays. One of the issues that I had doing this was trying to figure out, something that. Well, the original idea I had was just to take a motherboard and CAT scan it, or because I just recently tore my ligament in my knee, so I had to go to the hospital a couple times to get knee scans. And I was like, could I just do the same thing with the motherboard and look at it on the inside of the motherboard? And the answer is yes, that's exactly what you can do. I talked to a doctor friend of mine, and I brought this idea up to him, and he said the good news is that you can jack up the power on the CAT scanner because you don't have to worry about giving the motherboard cancer.
Do you have to worry about giving the motherboard a short circuit somewhere?
So X-rays won't short circuit. So there are a ton of, most of the material analysis techniques that I am familiar with involve literally disintegrating the item.
Right.
So things
makes it problematic for further use.
Yes, things like mass spec. A lot of the techniques involve shooting high power photons into the item, which will short circuit everything. It will give you really clear imagery, tell you where everything is, tell you all of the elements that exist.
Where it was.
Well, it's still there. It's still a bunch of silica next to each other. It just won't work anymore. So X-rays are non-damaging, which is the greatest thing. And they're not damaging to the item, and they're not damaging to electricity, electric components. So you can put motherboards through X-rays, then use them, which is great. There are 3 techniques. It's XRP, XRF, and XRT. They just stand for X-ray. The first one's FISO something. The first one is not possible. It is the best imaging technique, but it requires pictography. It requires a synchrotron and millions of dollars. So it's not feasible for enterprise. Well, so as a person that works for the government that has an unlimited budget.
Yep. I was just gonna say, is this what we're doing to the F-35s?
Basically, yeah. So I work for specifically I work for NNSA, which is National Nuclear Security Administration. So we have a very large budget. So this actually wouldn't be completely unfeasible for us to do because for specific computer components.
High sensitivity.
Yeah, high sensitivity ones. And its resolution goes down to 14 nanometers. So you can't that is really small. But there are great other options for enterprise that have less resolution, but because a grain of rice is really large, despite what you guys might think, in terms of material analysis, grains of rice are huge, So there are other solutions. Actually, fluorescence is a great one. I will use the graph to explain it. Here it is. These are a bunch of elements. When you pump X-rays into, I wish I had a whiteboard, but basically atoms have bonds, and these bonds have this very specific lengths based on the electrons and the size of the atom, and these will vibrate when you pump X-rays into them. And then you use a really high-powered device to pick up the vibration frequencies of these bonds, and it will tell you what element it is. And then it will plot it up on a really nice picture graph and draw you a heat map of everything. So actually, fluorescence is non-damaging. It's very easy. You just program something to look for the very specific peak of silica, which is somewhere on here. I just don't know where. But where did I put S? Where's SA?
Is it SA? I thought it was SI.
It is SI. Or is this? Did I just use this graph to show you what it is? These are just a bunch of atoms.
I was going to say, because that isn't on that board. Sorry,
nope, it's not. And I have a map of. Oh, this is what it looks like. This is just a rock, but with a bunch of different atoms in it. But this one has SI, and every little green speck is an SI atom, and you can like clearly pick it out from all of the surrounding like iron and magnesium and whatnot. It's a really good option. So you have to pick out Si from SiO2, which is silicon oxide, which is what the background surrounding PCB is made of. They have drastically different wavelengths. One's going to be about 3,000, the other's going to be about 3,300. That doesn't seem like a lot, but it is. Just trust me. And you can just program a computer to do it for you automatically. And then the heat image is generated by your computer, so you just program it to you focus in on that specific range, and then it would just glow. So you could dark out everything and then only have pure silica shine back.
This isn't catching surface layer. This is passing through the board.
Yeah. So this has about the penetration. It's called penetration depth and penetration angle. Penetration is about 1 centimeter. So a microchip that is somehow implanted up into one of the components on top of the board wouldn't be detected, but something that was detected on the PCB itself would be detected. So basically, if you can think about it, you dictate a floor and a ceiling.
There's a lot of boards that are less than 1 centimeter thick, though.
Yeah, most are. Yeah, most boards are less than 1 centimeter thick. I was thinking about like my home computer motherboard when I did this. It gets to do that. What you do is you dictate a floor and a ceiling, and then it scans everything in between that line. So you wouldn't be able to get anything that was above it, and you wouldn't be able to get anything that was above it, below it. But it's a lot easier to physically notice a microchip that isn't embedded in the board because it's just hanging out there.
What about like doing it in slices?
XRT does it in slices.
Okay. Skipping ahead. Sorry.
The last one, which is the not on this version of the paper, because I didn't have I only had one version of the PDF. But where's my mouse? It's stuck.
Over there on the left or right, yeah.
Oh, got stuck on that side. XRT is wonderful because yeah, here we go. You don't have Word, so it didn't format correctly, but that's fine.
Welcome to hell.
Zoom. How do I zoom in on this? I just hold Control and. Yeah.
There you go.
Whoops. jump. There we go. This is an XRT graph. So this is going to do individual slices of the motherboard over and over again. So this is the same project PCB. And like this is clearly where the processor is being held, and this is the circuits on the backside of the board. And what you do is you would slice it up. You would slice up a board multiple times, and then you just basically baseline it. And you would use an image to baseline it, and you feed that into machine learning algorithms. And then you would feed all of your test such cases into that machine learning algorithm. And it basically just like pick apart this board pixel by pixel and determine if anything is different. And this is like very low cost. So, and when I say very low cost, I mean you're gonna have to buy like a computed XRT machine. So that's gonna be like $800,000, and then you're gonna have to run them with a technician, which is gonna be like a couple more tens of thousands of dollars. But from an enterprise standpoint, it's not outside the range of some companies. Like,
why buy one?
Or yeah, you could rent one, or you could just pay someone. Right?
This seems like a space that you could easily spring up a business around. However,
you're going to have to get vendor support.
I have some additional questions.
Okay, yeah. So you would have to get, the problem with this is one, you'd have to get vendor support. So you need vendors to subject themselves willingly to this. Because like a lot of software vendors will send you the hash for their source code, so that when you have your application, you can check to make sure that it's the correct thing, so that no one's intercepted the software halfway through. This would mean the same thing. This would need a gold standard or gold disk like version of the item. Or you could just check it yourself, make a gold image, and then test it against that.
If you're going to collect all this data, at that point, use machine learning to your advantage. All right, so unless, and this is one of the problems I have with the piece that I believe inspired you to kick off on this dusty trail. The Bloomberg piece alleged that an entire line of motherboards, so every motherboard that was produced had an embedded chip that would do something on it. The problem with that approach from an attack standpoint is it's super noisy.
Yes.
Like, why rob every bank in the country? I want to rob the one guy that didn't realize I was robbing him until I had all the money and I was in the Bahamas. It's probably a really poor choice of destination. Not going to last long there. Whatever. You catch my drift. So the idea is to attack just the boards you need, right? Like, just own those. Well, it should be trivial to take an X-ray of every single board you've got and account for why is this one different. And it doesn't matter if that one's malicious. If it's different, chuck it, right?
Yes. So the reason that I like XRT is XRT is already used from a QA QC point of perspective. It's also used from a reverse engineering point of perspective. So companies will reverse engineer microprocessors by like using XRT to get a layer by layer image of the chip, specifically Intel and AMD, and then reverse engineer it. The problem with that is that you have to remove all of your current motherboards from production.
Do you?
You have to remove a number of them.
So here's the thing. If you're in a healthy environment, which if you've got the budget to spend on X-raying your motherboards, I hope to God you're in a healthy environment where you're actually replacing your equipment at a steady clip. Draw a line in the sand and just say, we didn't have this technology to verify our boards before. It's going to go in the untrusted universe. And then as you buy new ones, you build out a trusted universe.
Yes.
Where
So
you've X-rayed your boards.
This is great because it doesn't take long to do a CT scan of motherboards. XRT is basically the same thing as CT, which is slightly different. To do an XRT of a motherboard as it comes in, 1 minute maybe.
It takes much longer than that to disassemble it and get it out of the casing they send it to you.
Yeah.
Like, if I've got to disassemble my blade before I can install it.
The idea would be that you already had like pre-programmed baseline for like each version. Human automatically tell you if it was good or not.
Which in that, I mean, unless you're from a megacorp, and I guess ostensibly you would be, or a government entity.
Yes.
Yeah, you'd just be looking at, which the bigger problem I see at that point is, okay, I've got this board, now I bless it, it is sanctified and pure. I'm gonna ship it off to my data center somewhere. Now I've got this whole other opportunity for interdiction before it gets installed, or I'm gonna do this at every facility right before it's installed.
Yeah, so from my, I guess, yeah, you're correct. If you centralized your scanning, you would have to do that. But if you didn't centralize the scanning, you wouldn't have to do that. You just,
Yeah, 800,000 is that's a hefty chunk of a data center.
Yeah.
Or put it on a truck, I guess.
Yeah, you just wheel it around and do it all at one time.
So
yeah, no, we spent like I think we just earned $1.5 million like last month, just if we didn't do anything with it.
Yeah.
Literally set it on fire.
My company does the same thing, and we don't have the budget of the DOE, so you're fine. So from a hardware standpoint, though, how sensitive is this to defects in the board?
You have a 1 micron detection, so you can detect down to 1 micron. The reason why it's useful is that there will never be a defect that is silica bonds don't form in nature. They just don't.
Sure.
So you're never going to have a defect on your board that is silica by itself. And
you're saying there's never going to be an accidental chip.
Yeah, there's not going to be an accidental chip unless it accidentally gets soldered on. And at that point, so you're already having an issue.
I'm more wondering about, I guess, version 2.0 of this technology, where you're actually vetting each one of the chips that's on the board. So and there have been machine learning, or not machine learning, but neural net. So in training some neural networks that run on hardware, there have been cases where a neural net was trained and run on a particular board, and they took that code, like lifted that neural net and dropped it on another board, and it didn't run. It won't run anywhere else because that net learned the defects in that board and uses them as part of the computation.
Yes.
So I'm just curious, and I guess this is an unknown. You kind of have to test it and see, right?
Yeah.
But how well can we pick that up? And at that point, I'm less interested in the security implications of this and way more interested in, can you tell me which ones on my motherboard are going to freak out on the third Tuesday of the third year that I own?
I mean, you can couple this with machine learning. You can couple this with 3D printing to 3D print like an identical version of your board, like clone it. We're talking like millions of dollars here, but it's theoretically possible. You get 1 micron.
That's a movie script, man. You've got a movie script right there.
Yeah. You get 1 micron images. You can go down to 14 nanometers. You just have to fly out to California to Livermore and borrow their synchrotron.
I'm sure they won't notice.
We can go down to individual atoms if we go to Oak Ridge and use their spallation neutron source. It's $40,000 like a shot, so we could borrow that. The technology exists. It's just about trying to find what is actually feasible for businesses to use. I'm not going to. I used to work at Oak Ridge National Lab, and they have something called the spallation neutron source, which pummels photons and neutrons into an item until it literally bounces a neutron off every atom in the item, and then you know exactly what. Boeing comes in and rents the place out for a week, costing them like $30 million, and they test all their turbine blades because turbine blades have literal atom thick layers of things like chromium on them. These turbine blades are the most engineered part of an aircraft, so they're very concerned about having a little bit of extra atoms on one side of the internal blade because of
and they spend a very decent portion of their life at an altitude that they get bombarded with interstellar radiation far more than you or I. There's actually a thing where flight attendants end up with a higher incidence of cancer than the general population.
Well, so I don't know a lot about nuclear radiation. Things that increase your dosage of nuclear radiation are living in Denver, living in a brick building. There's so much radon in the soil in Denver.
That's not what I thought you were going to say as the cause. Okay, cool.
It's called the Denver dose. People measure things against Denver. It's like so you get about 10 millirems a day in Denver. Naturally occurring radiation. Naturally occurring radiation.
So far as we know.
and like everywhere else, you get 5 millirems a day. And if you fly in planes, you get more. If you eat bananas, you get more. If you live in brick buildings, you get more. If you live in a basement, you get more. Because radon is heavier than air.
Wait a minute.
Yes.
Bananas.
Yes.
Yeah, I know.
Potassium has a radioactive isotope that decays.
Huh. Cool.
Yeah, right.
I've learned all kinds of things tonight. This is great.
If you live near Fukushima, you get 34 times the Denver dose.
No, really?
If you live next to 3 Mile Island, you got 5 times the Denver dose. If you live next to Chernobyl, you died.
You mean that concrete melting is a bad thing?
Yeah. So, what was I going on about? This is yes.
The Boeing using it to test their turbines.
Yes. Oh.
That's where we dove off.
Okay. I was saying that that's a super high imaging technique. It requires you to have your own power plant, and they're part of Oak Ridge's. It cost $434 million in 2016 just to run the electricity for the facility. They have their own Tennessee River Valley Authority power plant to run the place. That is going to be your highest quality imaging technique, which we're not going to use. And then a really low one would be using high-powered, high-definition cameras, and then using high-definition cameras and machine learning to take pictures of the motherboard from different angles, and then basically determine where there might be something that has changed. That would be your super low-end technology. And then somewhere in between there is something that defeats the adversary.
Right. He's got to find that sweet spot.
Yeah, where you're not paying too much money. That's not too unfeasible. Microsoft could afford this. Microsoft, Google, Facebook, Amazon.
Yeah.
They can afford the U.S. government contractors, Lockheed Martin, Fortune 500 companies. They can all afford this technology to use, especially if it's going on a Hellfire missile or the F-35.
So, how subject to? because
this system itself would be air gapped. If you want to talk about meta and
right. We've already talked about how air gaps are super successful.
Yeah. So but it's at the same time of it's just insider threat, right? How well can you defend against insider threat? Can you really?
Well, and that's the claim with the Bloomberg story on SuperMicro is it was not that they infiltrated. They have an employee on the inside. You pay a guy $500,000 and hey, look.
SuperMicro isn't about having an employee on the inside. It's about having an entire manufacturing facility on the inside because that manufacturing was a subcontractor in China.
Sure.
And they have to bend down to the Chinese government.
That's the entirety of our industry, right?
Yes.
All of the chips are made on that side of that half of the globe.
Yeah, but the blueprints usually aren't.
Which comes back to the question I was going to ask, which is how frequently does blueprint change?
You would have to get a new version. How frequently do baselines change? How many CSI versions of Windows 10 are there? 15.
Yeah.
CIS?
Is it? I don't understand the level of complexity. How frequently do they update the chipset on the motherboard?
I have no idea.
Yeah, me either. I know nothing about that industry. That would be the only thing that would terrify me is you go to conquer this problem and end up with 4 billion layer or like different iterations of motherboards for those.
So
we made 70 of these motherboards total.
Well,
and that blows.
So the idea would be that you would just go to the vendor and they would give you the image. You would have to. I write in this paper that in order to make this sort of imaging successful, you would have to get complete vertical integration.
But so at that point, you have to trust the vendor and their manufacturer.
You already have to trust the vendor. You already have to trust the vendor. What software do you run? Do you have Microsoft products? What happens if Microsoft is compromised?
Right. But
what happens if your patch Tuesday security update
so this doesn't
has malware in it?
This doesn't address the issue of a vendor that's compromised by the fact that it's located in.
It's solving the issue that vendors, most hardware vendors, most software vendors that you're going to be dealing with, their headquarters, their main part of their company is in the U.S. and then they subcontract out either their manufacturing or like some of their coding to overseas. So while the part of the company that's making the hardware is going to be in China, it's not necessarily, the company itself. It's not their HQ.
Sure.
So what you would need was the company itself. I mean, almost every organization is already extremely susceptible to waterfall attacks. It's just part of the industry that we currently live in. It's part of the way you go to your vendor for patches, and the patches are compromised, then you're compromised. The vendor was compromised, you're compromised. This would rely on either you going through the hardware yourself and determining whether it was solid or not, or 2, vendor gold images from the prototype that makes this motherboard and then verifying it against that. So a great example is that we use Emerson products. Emerson is based in San Antonio, Texas, and they send us hashes of their software. And then we actually order their software from Singapore. And then when it comes, we recompile it and then hash it and then measure it against the Emerson hash that they sent us straight from San Antonio. If those don't match, we don't use it. That's a way of validating software. Now, if the hash is originally compromised when we get it from them, then we're just kind of shit out of luck.
Right. Yeah, if the guy that's designing it put something in it to backdoor it, then
yeah,
you're kind of sunk.
Someone asked me the other day at work last week, what would happen if I hacked our company? And I was like, well, when a security incident happens and the FBI comes, or IG comes, or the NSA comes, or I'm like the #1 suspect.
Or some combination thereof.
Yeah, I'm like, I'm the #1 suspect because I'm a system admin who's a penetration tester for ICS systems. So like, something happens to our ICS network, they're like, first we'll check out Mackenzie, and then 2 we'll start going from there.
Mackenzie, why don't you have a seat in the back of this van?
Yeah.
Don't mind the hood over your head.
So that was what I said was, inside a thread is something that you can't really deal with. It's very hard to deal with. I mean, we have to do polygraphs and go through security clearance backgrounds, but
and so the other thing that this brings to mind for me is a concept. It's very rare to find one person who, in an organization that produces a complex system like a motherboard, that understands the whole thing soup to nuts, like that can look at a piece of the board and look at a piece of the schematic and go, yeah, that piece is to do this and it should operate in these ways. With enough detail to tell you, and it may be impossible for a human being to retain all of that information, to be able to tell you, yeah, this is a golden image that has 0 defects in it. So that's another interesting challenge in this space is how small a circle of people can you draw this down to that have to be trusted implicitly by the nature of who they are and what they've built.
I mean, ideally, it would just be the design team from the manufacturer,
right,
and like your company or the world, right? So it would just be like these images. Like I can go download the CIS image and our baseline and grab its group policy and push it out to any machine to secure it. And it's just like sort of communally trusted that is a secure baseline for our computers, right? So ideally, I guess SuperMicro, I don't know any other ASUS, which I guess is just a company that puts their logo on SuperMicro motherboards. It's apparently SuperMicro manufactures like 60% of all computer hardware, which is something that I didn't even know was a thing until I started looking into it. I didn't even know that they were a company, and they're basically like the Microsoft of hardware. But for example, you just have to go to SuperMicro and they'd be like, okay, we've now produced this item, this PCB motherboard, this server blade or whatever, and said, here it is. This is the prototype. Here's the gold image. Now we will tell our subcontractor in Tencent, like China, to start manufacturing this prototype. And then you would judge all the prototypes, because what they already do is do QC. So what they do is they have their prototype, and they look at the ones that are coming off the line to see if it matches. Now, as long as that prototype isn't, messed with, then all things coming off the line would be,
How much research have you done into the QA process to detect?
Quite a bit about QA, and specifically just like manufacturing.
Is that just a visual check, like they look at an image for
pretty much what it is. It's basically this, just like amended slightly for a security posture. Now, assuming, since the SuperMicro hack is not real, but you would just skip the QA step. And they only QA certain motherboards, right? You're only going to QA 1 out of every 10,000 motherboards. It's about what they do.
Really?
Yeah, we don't QA check everything.
That seems like a real low
1,000 motherboards. But it's like 10,000.
Sure, yeah.
It is actually like 10,000 motherboards.
Yeah, I'm sure it's much lower than I would imagine. Like if I'm producing something, I'm like checking every single one. They're looking at like, yeah, no, we got this, it's fine. The machine just made it. That's right.
Yeah.
Is that something that they could spider web out? Like if they, QA fail one of them, then they go out to like the lot around that.
Yeah, that's mostly how QA works. You would just pause the shipment. Once you notice the QA one, you probably go back to your last QA check. At least that's how our company does QA. I can't speak for every manufacturer who does QA and how they do their QA process.
I thought you said you've done research.
Oh yeah, my bad. I'll come back to you in 7 years. I don't even know if I could do research fast enough to beat companies that are coming into existence.
Right, yeah, no, I don't think you could. That's another one of those things like...
The privilege access user risk that you're talking about, something I've been working on with my system.
So what are they?
What I call privilege access user risk.
Okay, privilege access user risk.
And something to work on with my system, which I'm building a document system.
Okay.
And basically it's designed so that even if the domain admins and the database administrators got together, they can't actually get to the document data or even see it in the system data. So it looks just like a regular file system to the end user. It looks just like Explorer. You open documents and you save documents. But your privilege access users can't see what your documents are, and they can't get to the data.
That would be great, because we actually,
as a systems administrator, that doesn't sound great at all.
that sounds great, because we just accidentally made everyone on the system domain admin last week. So
no, basically the system gives from an administrative perspective, it's an easy system to administer. Right? There's no reason why the system is seated. There's a moment of install where the whoever is the top of the organization, a non-technical user, seats the system. It's kind of like it's kind of like when you're using a wallet software for like Ethereum or something. You choose a series of words, 50 words, and that gets locked away. And there's no reason for any administrator, any technical staff to ever see that. And the only thing administrators do is give people the ability to create groups. Okay, so if you're like a master administrator, you can give somebody the ability, you can create groups, but you can't go unless that person gives you authority to see what's in those groups.
Is there like one super duper user on your, or is it just like if data is lost, it's lost?
No, basically the way it does, there's also applies a lattice security model.
Okay.
So that for example, on the prototype system, there's 5 levels like associates, regular employees, managers, senior managers, and executives.
Okay.
And everything just rolls up. So if you leave the company, then your documents roll up to the next user,
Okay.
and then so forth, and really to the last person standing, who would be the executive committee. So
Okay.
that's how documents, and it also forces, so any type of secure group that's set up, there has to be owners of those groups.
Okay.
And the system, for example, if two people set up a group and one of them leaves the company, the system will not put anything, or if they both leave the company, the system's going to force their manager or somebody to assign ownership.
Okay.
So you can't have orphan data.
All right.
The main thing is that a domain administrator, somebody has his credentials, cannot go in and see what the CEO has for the documents. Even if somebody got into the network, all data in transit and at risk, and even in transit, in addition to HTTPS, the data is encrypted in addition to the HTTP sensitive data. So even if you try to set a man-in-the-middle attack, you're just going to run into encrypted data.
So for this system, domain admins can't look over your shoulder, essentially.
Right.
If you get hit by, if I have a document that has vital data on it and I get hit by a car, how would that data get passed to my?
So at some point at the top level of the organization,
Okay.
organization like a pyramid, every user has to have a report to somebody.
Okay.
And so so the administrator, all they can do is roll your documents up to whoever you report.
You basically can't have a user that doesn't have a direct supervisor or next tier up.
Yeah.
You enforce that as to have that, you have to have a username. Like those two, you can't have a user that doesn't have a username. You can't have a user that doesn't have the next tier up.
So that's why you have the top level group, the executive level group, or the small group, and at that special case, at the CEO level, that would have to roll over to a specified person in that narrow group.
Rolls sideways, basically.
Yeah.
Okay.
Yeah.
The ladder. Yeah, roll
Yeah.
sideways.
But you have to
And-
remember,
It's a little pedestrian to say if you get hit by a car.
Sorry, we call it the bus, train, and plane
Sure,
program.
I'm just saying in your universe it could be like high energy radon beam or something.
Okay, first of all, we have excellent nuclear safety. Thank you very much. All right.
Sure, I'm just saying.
We have never had a death stick turn blue. All right.
like in this scenario,
That's
even if you had a
terrifying.
We carry death sticks. Thank you very much. They're called dosimeters, and they're white. And if they turn blue, you've died. So
Is there an in-between shade or is
no. It's not for you. It's so that when they identify our body and see that we got hit by a lethal dose of radiation, we get 5 times our insurance payout. That's the only reason we have it.
You carry this on you?
Yeah, I carry it on me on my lanyard. It carries right here. It's called the death stick. Swap it out every once a year. I carry a different dosimeter that measures regular radiation dose. And it is a badge that I wear on my chest, and it measures how much radiation I've been exposed to. And then they send me a report every 3 months telling me how much additional radiation I've been exposed to. And then if I get exposed to enough radiation, I get to go home for the rest of the year.
paid or
Yeah, because there's a government, we're only allowed to be exposed to 5 extra rem of radiation a year. And which is 10 times the yearly dose for being outside. But as a radiological worker, that's how much additional radiation you're allowed to be exposed to in a single year. And then if that gets hit, you have to go home for the rest of the year because you can't be exposed to any more radiation. And then you turn that dosimeter badge in every once in a while.
Has anybody ever been hit the limit?
In different DOE sites, yeah. There's a specific core that they call the demon core because it's killed 6 people in 2 different facilities.
yeah.
Well, the guy was so in that specific example, the guy was tipping a barrel and he like was bringing the barrel forth, and then he slipped, and then when it tilted back, it became close enough to the other radiation source to create a criticality, and that's where you get like the blue flash, and then just fall over.
Yeah, basically it's an instantaneous chain reaction where
Yep.
like that reaction sets off the reaction next to it, 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 and yeah.
And then and on the specific area that I work in, we use tritium, which is like the most radioactive thing ever, and there is no protection for tritium, so just we have tritium detectors, but like we don't have any personal tritium detectors. So yeah, there's like all these safety controls and stuff that are pretty cool. And like they showed the chart from like since 1951 going forward of like how much radiation they've exposed all of their workforce to, and it like started at like 60,000 rem.
Because it includes the guy that dosed himself in the demon.
Well, no, that was out Los Alamos and Oak Ridge and Cynthia and Livermore. It's never happened at Savannah. We've never had an unaccidental criticality.
Oh, this is local to Savannah?
Yeah, so yeah, our facility has never had an non-purposeful criticality, because we used to have 5 reactors running, and those all run at critical states. So they're supposed to be critical.
Right.
But we've never had an unpurposed critical. But we have exposed people to radiation because things are radioactive and they're just slightly decaying every once in a while. And they used like 64,000 rem in the 1951 when they were building the facility, and they just didn't have any idea what safety measures were. And then like it goes down and down and down, and then like in the late 90s, in the 2000s, it's a lot better. And then there's like one case in like 2004 where there's just a giant peak of like 2000. And I'm like, I don't know what that was about. And no one will tell me what it was about. But we're at like, I think last year was like 64 reps.
Steven got really drunk and he opened the wrong closet, and
so we got like 64 reps last year, which distributed across 1,000 people with barely anything.
right.
So, and I don't even usually work in radiological areas. I work in a server room, but there is one process control module that is in a radiological room, so I have to put on the hazmat like yellow suit and then go in there and swap it out once every 10 years. And we actually just did that like 3 weeks ago. And it's really hard to hook up wires with like giant gloves on.
With spacesuit gloves?
Yeah, with spacesuit gloves on. So, but I don't know. How did we go? Oh, yeah.
You mentioned earlier about
My fault.
Plane, bus, and train. Well, we got 51,000, or we used to have 51,000 employees. Now we have 14,400 employees. So like that's a very large number of people that like deaths are just very common.
Right.
Statistically speaking.
Sure. Yeah.
Yeah. So.
And you're right. You're way more likely to get hit by.
Also, the average age of our workforce is like 47. So it's pretty up there.
Right.
Because what actually that is 5 years ago, they realized that the entire workforce is getting ready to retire in the next 10 years, and they just hired a bunch of young people. So that's like, it's 47, but really what that means is like 20% of our workforce is like 22 to 26, and the 80% of our workforce is like 50 to 75.
Which it's better to realize it now than to have realized it when a third of them had retired and gone.
Well, so about a third of them have retired. That's why we have 100. That's why we have 1,200 openings.
The retirement board, right? They had that happen where like their entire workforce collapsed because they had.
Right.
Oh no! In 5 years, our workforce will collapse. Almost guaranteed. Because the problem is that they've cycled the movement from a entry-level position to a mid or senior level position with their workforce retiring. So you hired a bunch of like millennials, and those millennials are going to want to leave once they've acquired enough experience to qualify for a senior or mid-level position somewhere else. And they've synced that up really nicely with most of their workforce retiring. So all the people, we currently have 1,200 job openings. And then, they've synced up, we have 5,000 people retiring in the next 5 years. And hey, our CISO positions coming up in March. No one wants to be a CISO.
Sure.
I applied, and I told them that I wasn't qualified on paper, but I was 100% confident I could do the job.
And Have you testified in court before?
Yes, lots actually.
Really?
Yeah.
How long have you testifying in court over?
My parents have been to court 21 times with each other.
Jesus.
Yeah.
Okay. Because that was the most uncomfortable thing I did while I was in the senior security chair at state, was having to sit in a courtroom and testify on shit. And
Yeah, I assume that normal courtrooms, family court is a different court than regular.
Yeah,
But it is an uncomfortable area to be in. Especially,
when
it might
someone's
be
yelling
even,
at you and there's a judge.
it might even be more uncomfortable in family court because you have to like do it in front of your parents.
I was just thinking. All right, who am I pissing off today?
I want you to know that it's 21-0 in that court, in those court cases though. It's really bad.
Jesus.
All right. I was hoping that this paper made sense, and just to like, I always sit in the back very quietly, but I live in Aiken, so I drive up here for hiking once a month.
Maybe you have the domain expertise of one about.
Definitely don't, but I'll help you.
At least if you don't, just lie and make it sound good.
I like this
guy. Huawei, how do you say that? The Chinese.
Huawei.
Yes.
Yeah,
so,
Huawei. It's Huawei.
So is that a real security threat, or are we overreacting? Because basically, we are.
So in order to answer your question, I will tell you what they told me when I was doing my CMBD training, which is my classified material control training, which is there's a ton of top secret and classified material that you can find on Wikipedia, and that is public data. And I said this when I was going through the training. I was like, how comes this is secret data, or secret restricted data, or top secret data, or top secret SCI data, when it's literally in the front page on Wikipedia? And they're like, because it's on Wikipedia, it's conjecture, and now that you're a government employee, if you comment on it, it gives it credibility. And that's why, even though it's public information and you knew it before you became a government employee and before you got top secret clearance, you're no longer allowed to comment on it, which is absurd to me. Also crazy is that you can take 3 sets of non-classified material, and if you put them together in the right order, they're now classified, which is mind-blowing.
That makes a weird sort of sense to me. But this is an interesting area to me that I think may end up changing over the next decade. And the reason I say that is it's from a school of thought where if you confirm something as a government entity,
yes,
you tip your hand about what you know to be true.
Yes.
And from a statecraft or from a spycraft standpoint, that's game over. You've lost when you've done that. You never want to tip your hand. So Russia's kind of shot that in the ass in the last 18 months, 2 years, because they've basically just been like, yep, nope, we kicked Crimea over. What do you want? And they've got no qualms about saying, yeah, we kicked over Ukraine's power stations, all of them. We blacked out all of Ukraine with the internet. Deal with it. And that sort of cavalier, like, I don't care that you caught me. I have to believe that it's going to change that calculus at some point where, like, there's no value in hiding the fact that I know how you did this. Like, at some point, I'm like, yeah, I know how you did it. And by the way, your power is going to go out in 12 seconds. Bye.
Yeah, I don't know. I don't get to make those calls.
I'm sure. There's not a single person in this room, and I'm totally talking out my ass.
Yeah.
There's not anyone in this room that qualified to make that assessment, but it's going to be interesting to see how that plays out over the next decade.
Okay.
I think, but yeah, as for the Huawei thing, I'm honestly skeptical of any piece of kit produced in China at this point because of if you look at everything their government has done, they've made it abundantly clear that they have zero problem stepping in and telling a company how, when, and why to produce their stuff. And if they want to own every router in America, all they got to do is manufacture the things. And what have they been doing? Manufacturing the things. Go and do some reading on BGP hijacking, specifically around the Chinese hijacking US ISP BGP routes that basically cause your internet traffic for your ISP to hit your ISP. When it leaves their network, it goes to China, then comes back, and then goes where you want it to go.
There's a great way to detect that, and your TTL packets will go up by 1.
It will.
It's the only way to detect
by 1,
BGP.
and the TTL couldn't go up by 1 for any other reason.
Yeah, right. Just because it was slightly faster to go to like Chicago versus like Cleveland real quick before,
Right.
Because of like internet traffic on that one day.
Right.
But for entities that have very specific VPNs that are like, for example, our mail server, all mail is hosted in Port Meade.
Yep.
So we know exactly what the TTL is supposed to be when it goes there and comes back.
And I would imagine with certain links, you know the light speed travel time of the data, and it should arrive within this many milliseconds.
No, it's too many of our new employees are watching YouTube videos to eating up all.
Why is that on the same network?
Eating up our bandwidth. Well, I have like 4 computer stations at my desk, so I can watch YouTube on one while.
Have y'all read the Time to Live email mystery?
No.
Okay, so I'll find this and send it out since I'm telling the story again. In the late 90s, early 2000s, there was this forum post from a guy who had a college professor come in and say, I'm getting emails bounced back from people who are further than 500 miles away from me. And the sysadmin went, bullshit. There's no way in the universe that could happen. It just doesn't make any sense. Long story short, does a ton of digging and finds that the mail server had been configured incorrectly, that the time of the light speed travel time past that distance, it considered a timeout and dropped the traffic.
Oh, that's amazing.
Isn't it?
Okay,
It's
so
fascinating.
speaking of mail access, a hack that the new standard, because I just had an FBI meeting today. The new crim like bread and butter is to go into your not mail like for Office 365, not your mailbox account, but to your user profile account and set up your user profile, configure your user profile to auto forward mail that hits your user profile, and it's not a mailbox rule, and it won't show up in your sent or forward in folders, but your mail is being forwarded to another email address. And they put it in your you can configure the user profile to send it to 2 different mailboxes when it gets hit. So
What? Oh, wow.
that's unclassified. So you guys have fun with that one.
Yeah, I want to dig that up. That sounds like fun.
So you can configure the user.
I would pray that Google would at least maybe warn you about that. But
Well, I don't know
maybe not.
about Google. This is an Office 365 problem.
Oh, fuck.
Right.
Let me tell you about Office 365 and how much I loathe it. But yeah, okay. Cool.
So that's fun stuff.
Do you mind sending us out to the group in some form at some point?
Sure, I have the most updated version at home. There's I think the first one was version 4, and now we're looking at version 5, and I'm on version 8.
And so you're producing this with work?
No, so I'm doing my master. I'm doing my master's substance to the STI.
Gotcha.
This is one of those papers.
Very cool.
So this is
Yeah.
not your work.
As
Everything
long as the Men in Black don't show up,
everything that I would produce from work that I'm allowed to show to people has a giant red stamp at the bottom. It says DCRO, the name of the person that DCRO'd it, and the classification that it has, which is always going to be unclassified. So,
if we're seeing it anyway.
yeah, yeah. So.
Enjoyed your presentation.
Oh yeah, no problem. It's for I like hearing about your fun format.
Thank you for coming out.
Yeah,
And,
thanks.
Next month we'll be at Conquest Brewing, but we'll be back down here in January.
Cool.
This is not our usual week. Normally we would meet the 3rd Tuesday of every month,
But Thanksgiving, so.
yeah, but Thanksgiving next week. So.
Have a good.
Yeah, see you later.
Yeah, so.
Thank you for giving us a very interesting meeting from the ashes of us not preparing at all.
No problem. Yeah, this is like a side project that I've been working on. It's more about, I read the SuperMicro thing, and in the last paragraph of the SuperMicro thing, there's a sentence that says, there's no way we could have seen this detected in food. And then I read the Krebs on Security article about the SuperMicro paper that said, that was an interview with someone who said, there's no possible way that this can be detected. And I said, bullshit. I can do absorption analysis of packing material inside distillate columns with some sort of material analysis. Do this. I just don't know what it is. So then I called a couple of people that worked at NIST, and then my ex-girlfriend who is a PhD in material science, and then she let me borrow her $4 million laser, and I came up to USC to Horizon. And I used their Raman X-ray diffractor, which is like very millions of dollars. And then I just took I have a bunch of computer parts that are just in my garage. I took an old motherboard and I hacksawed off like 2x2 inch part of it, and then it's like.
I've thrown one into a smelter before and watched it melt. So.
Yeah. this motherboard had nothing going for it. All right, it's like from 2004 with like some crappy AMD chip on it. And then I put that in the laser and shot it with the Raman laser, and then got the images. The reason that's not up here is because Raman doesn't have enough penetration depth that you could hide something in the middle of the plastic.
Between the wafers
yes.
or whatever. Yeah.
And then two. It took a while to get good imagery of it, and it looks cool. It just
I would imagine.
Also, they're $4 million, so
I would imagine it's like most scientific instruments, and you have to learn to use the instrument.
Oh yeah. There's no way I would do it. I needed like a PhD student to do it for me. Also, it takes 24 hours to do a 2x2 inch section of it. Right. So not exactly. These are all really fast. These are all basically instantaneous.
Zap it.
Hey,
look.
Here's a picture. You know how long it takes to get a CT scan on your like leg or like an X-ray? You know, walk outside, press the button, walk back in. This is what your teeth look like.
Right.
This
is what your teeth look like, and you have cancer now. Congratulations.
So this is what this technology is about. So log out of my email.
Yeah, that was one thing that drove me bonkers until my sister got a PhD and explained it to me. Was the scientific community not like sharing the raw data off of their instruments, but she's like, you have to spend some time learning what how the instrument's biased, and that every single instrument in the world that's at a high enough caliber to do most of the science that's useful is sort of a one-of-a-kind beast that was assembled by the people using it. And it's not like, well, you go to a Radio Shack and you buy the microprocessor X-ray machine, and like it's not the same.
Yeah.
But anyway,
you could build a machine that specialized in this, and then like had the software built into it that would do the machine analysis.
But how do we trust the machine?
Well, then you just quit and you go back to tin cans and a string, which I have one of those in the office because we're not allowed to have any sort of electronics or anything like that. So like the person on the cubicle wall, like on the opposite side of me, we have like a tin can, like up in string, like for fun, as a joke. Yeah, we're not allowed to have anything. Fitbits, not allowed. No phones, no watches, no CD players, no cassette players, because apparently cassette players can record. I was like, could I bring in a, what's it called? The giant disc.
Laser disc.
No. We got those though. Record player.
Oh God.
But you can,
I was terrified that that's what you meant.
And they were like,
stop being such a millennial.
Record players have recording functions where you hook it up and it has the giant like thing.
Yeah.
Not allowed.
What?
Not allowed. So.
Hey man, what's up?
Yeah. Anyway, that's what I do.
Awesome.
That was cool.
Yeah, that was good.
Yeah. Glad you had that. Way more fun than any of those.
Yeah, well, the nuclear stuff is fun just in and of itself because I like work in a facility. So PLCs are fun. Industrial control systems are fun. On Thursday, I am presenting a pen test, tabletop pen test exercise on one of our nuclear facilities to senior management, and I work with the Army as well. So I don't know if any of you guys know what the cyber protection teams are. They're basically just like Army groups that do cyber.
Yeah.
So I work with the Army. I worked with Army Cyber Protection Team number 3, which is based out of Augusta, because they don't know anything about industrial control systems. So my goal is to work with them and teach them about ICS and like this is what a SCADA system is, and this is why our power grid is doomed. And then it's they work with us on some other stuff. So that sort of programmable logic and stuff like that is what a lot of what I work on, and authentication. I don't know. We're all doomed. The power grid is shot.
The fact that you guys are just like strapping security onto all of the pieces makes me super sad inside.
Okay, so
I get why. I understand the mechanics of it. I just hate it.
Here's the problem with our industrial control systems is that our vendor will null and void the support contract if we put software on the system that they don't approve, which means no IDSs, which means no active scanning, which means no this, no that. Like, it's insane. And then the production system itself, like, nothing.
Because you could send a stray bit to one of these PCL, like, and it'll just...
Yeah, so it's pretty easy. So the first thing, I started working there, and I think about my 3rd week or 4th week, I completely decimated our entire development server. So we got 4. The idea is that we have layered and fed. This is like the cream and crop. We got 4 systems that are mirror images of each other, and we move from development through like this, development 1, 2
yep.
to simulation, to training to simulation, and then eventually production like 2 years later. So if we do get hacked via like a USB drive, hopefully it tries to execute itself sometime in like
training,
yeah,
right.
or simulation, where we just like actually plug it up to a bunch of PLCs that just generate fake data, and just like we run it for like a year and just see what happens.
Weird. The simulation nuclear reactor exploded.
Yeah.
Why did that happen?
What was that, war games?
Yeah. Yeah, I leveled our entire development network my like 3rd week there. And you know what I did was I updated Symantec from 12.1 to 14.0, and it destroyed everything. Not only the workstations, but the PLCs, the switches had to be reconfigured, the servers had to be reconfigured, our historian, our everything just had to be taken down and rebuilt. No idea. Symantec, and I came into work early that day, and because I wanted to get on the boxes, because we have to go box to box to update. And it was only like 10 or 14 workstations because there's like 10 or 14 developers. And I was going box to box to update from 14.0, from 12.1 to 14.0. And I got it on 2 boxes before they stopped networking. All the boxes stopped networking with each other. I don't know why, and none of us know why, but it just like the entire thing just went down. Because Symantec hadn't approved 14.0 yet. Like,
can I get one of those death sticks?
Yeah.
I need it.
So yeah, all of our we can't even install patches. So when vulnerabilities come out, what happens is Emerson has to approve the patch first, and then kicks that patch out to us, or edits the patch with their coders to be Delta V friendly, and then kicks it out to us.
Which God knows what that does to how, like.
I don't know. There's some vulnerabilities out there that Emerson just said we're not going to fix these, and we just keep a running tab of them.
We can't fix that,
and we
it breaks the functionality.
Yeah, we come into our like baseline reviews or our audits, and they're like, yeah, how comes your Nessus scan has like all these vulnerabilities, and we're like, Emerson says we can't fix them, so we can't fix them, and they're like, okay, that's it. That's all the objective evidence we needed. Like, this is our like 26 like critical vulnerabilities. Like, just don't worry about it. Like, going back to like since the operating system existed. Yeah.
Nice hoodie, by the way. I just realized you have a Red Hat hoodie on.
Yeah, Red Hat, by the way.
Yeah.
Sound Life, IBM. Do you work for Red Hat? Oh, okay. Wait, now you don't. You work for IBM. Good question.
Yeah, right.
Good question.
That is very good.
Yeah, I just put a little thing in the Slack about if anyone was looking for work in Aiken. So I just realized that coming here today. I was like, oh, I could get like a bunch of job openings. Maybe someone wants to move to Aiken. It's really nice. I just bought a house.
Yeah, somebody has family down there, so.
If anyone wants to buy a house, I'm thinking about moving. So
Why are you moving?
um,
Are you moving away from Aiken or just in Aiken?
oh no, probably away from, I don't know. And like my 401k gets vested like soon, so thinking about moving. But
That whole invested.
I went in to ask for promotion, and they said you haven't been working for 3 years, so you can't get promoted. And I'm like, yeah, but what about all these other things? They're like, yeah, but you don't meet the time requirement. I'm like, what about our policy and procedure that says you can't hold someone back solely based off of time requirement? They're like, haven't been working long enough. I'm like, that doesn't make any sense. I'm like, I'm the only person that I know, like, like a year and a half ago I started, and I was a chemical engineer, and I knew literally nothing about computer technology, and now I have like 8 certifications, and they're like, you still get paid the same. Like
That's a recipe for getting you out the door.
I'm like, you spent more on my training than you did on paying me this year. I don't see how that's fair, and like how I couldn't even get like like a 3% raise or anything like that. So like, just gonna hold tight. I do have my APR coming up at the end of the year, but I am getting a new manager, so my manager is leaving, and then also our director is leaving. So our director is retiring, and so is my manager. They're both in their 60s. So so new people will be coming in. I don't know anyone on my entire company that's qualified to be a CISO. I'm like one of 2 people that have the CISSP. I feel like it's a pretty entry level certification for manager.
Sure, if you consider requiring 5 years of experience in the field.
Yeah, but for being like a CISO?
Sure.
Okay. Yeah. I feel like it's pretty entry level. It's just like, it's a very backwards place when it comes to cybersecurity because
it sounds an awful lot like a government entity.
yeah, we are a government entity. Yeah, it does. Am I describing a government entity to you? Hey, when we worked at TQ, we didn't have cybersecurity. I was a developer, and we worked on AWS, blockchain, and IoT, and we made a prototype car that you can go through that white paper too. That was 17 pages long on how
Don't threaten me with a good time.
how blockchain and IoT can prevent automotive insurance fraud by basically souping your car up with IoT devices and then bootlegging off of either like your car's OnStar program or your cell phone to render all that data to the server so that when you finish crashing your car, you had already had an insurance claim filed. Because you could use how many people were in the car, you use
I don't want that.
skip. I was trying to like do my job.
No, sure.
So we like uploaded this all to an AWS database, and then we got it configured in like the NoSQL database under DynamoDB, and then it was parse out to go to S3 storage, and then go over to Redshift and do all this other crazy stuff. And I wrote all this Lambda code, and there I wrote Lambda code that accidentally opened up a SQL server from 2 to 4 in the morning and downloaded all of our data to it, and then deleted itself. And that cost us like $3 grand that month on our tiny development server. And they're like, where did this all come from? So we stayed up like 24 hours watching the Amazon our AWS account to figure out what was happening.
See, that's what I love about everyone's like, oh, it's going to be cheaper when we go to the cloud. I'm like, yeah, assuming none of the developers does something that causes it to accidentally spin up 3,000 instances of something.
Yeah, nested like VMs by accident.
Right.
But that was great. And then how did I get onto this stuff, blockchain and stuff like that? I bought a bunch of Ether when that happened, and then I sold it and bought my house. So that was amazing.
Sure.
So that's like the best thing that came out of that job.
Yeah.
And then we got bought by Capgemini. Capgemini was like, we don't do research and development, it's just like extra and hire staff. So
That sounds exactly like Capgemini.
so
Low risk. No, we have a product. Go away.
yeah, so
We bought and paid for it. It's fair and square. Leave.
but it's mostly just about thinking outside of the box is what these things are for.
Yeah.
Because almost all PhD work is about almost all research that's done by universities isn't applied anywhere ever. It's just about feeling out the edges of the field and boundaries, and like half of it's actually wrong. Half of PhD dissertations are just factually incorrect. But it's about like working on it, and then like people will go and do like either review your work or do supplemental studies, or they'll build off of your work and then realize you're wrong, then redo all of your work and then go further forward. And that's what these are. It's like my thought experiment of being like, how come you guys keep saying that this is impossible when I think that it's possible? Here's an idea. Here's like 16 citations. Please take this. Also, trying to flex on people with a chemistry degree.
Right. When are you getting this circulated?
Like February.
Okay.
So like a 6-month process.
Yeah. Very cool.
That's sweet.
And it probably has to be longer, and I have to redo my citations because it's not currently in APA format.
I'm sure.
Oh, yeah,
The format gods must be appeased.
Yes,
Yeah.
format guys have to be appeased. So
White papers are awesome for that. I used to go bang around with like digital forensics white papers when I was trying to figure out if we could do something with something. And
Right.
you just come up with like, oh, well, they were studying this, maybe this will work. And left turn and go crazy.
the other white paper idea that I'm working on is about that level 1 knowledge. If you push electricity through a copper wire, it produces inductance.
Right.
Inductance has a measure the flow of electricity, and then you can use that flow of electricity to figure out what bit sequence is getting sent through the wire.
Right.
And then you can use that bit sequence to figure out whether your PLC has been compromised.
Why wouldn't I just use a wiretap for that?
We can do like tap. You're just gonna like tap the copper wire.
Yeah.
I mean, break your industrial control system.
Well, I guess, or you're not talking about the network layer one,
Yeah, I'm talking about
like Ethernet?
no, I'm talking like PLC to actuator.
Yeah. Okay.
So
Yeah, you will break the industrial control system.
yeah.
Well, so
here's
measuring the ductance isn't going to have any impact on the.
No. The inductance is being produced regardless of whether you measure it or not. For you forest person there here.
Okay.
Um,
I don't know if the measuring tool it produced some
Yeah.
sort of signal on the wire.
well, that's something to be considered. Does it produce? There's a great PhD researcher in Israel who you should visit his website via someone else's computer that specializes in jumping air gaps. And he has this huge paper, and it's like 285 pages long, and it's all about the 8 ways you can jump air gap systems. And you can one of them's RMF, one of them's just removable media, one of them's about all this other crazy stuff about supply chain interdiction, and then coupling that with some sort of other technique. There's great examples of people installing radio transmitters onto an air gap system, and then sitting 2 miles away with their computer and just transmitting via radio waves.
Pringles can and Halo.
Yeah, exactly. So
We're on the inside.
yeah, 40 meters of concrete, but we're currently entering the time. So today I left work slightly early to get up here in time, so I got to see the sun today. But we're currently entering the part of the year where I don't get to see the sun for 4 days a week. So from Monday to Thursday when I work, I get to work at 6 a.m. and then I leave at 5.
Yeah, no, you don't see the sun.
And I don't get to see the sun because there's no sun underground. So fortunate. Sometimes they go out for lunch.
That would be a new requirement for me this time of year.
Yeah, well, we recently have had a large issue with people taking 2-hour lunches because in order to go out to lunch, it has to be for 2 hours. So you have to get out, walk up, move your car, which is half a mile away, drive off site, which is 7 miles, and then drive to town, which is another 10 miles. But I was gonna do it today because I wanted Chick-fil-A, but then I was busy.
They can't bring a food truck on site, I guess.
We
not.
do have food trucks. They don't really good though.
Yeah.
Although I am currently talking to our division leader about doing Chick-fil-A Wednesday, where we send someone to get Chick-fil-A sandwiches for everyone on Wednesday.
Actually, if you call Chick-fil-A, a lot of the restaurants will send their van out with loaded loaded up with sandwiches and stuff.
Yeah, so the van can't come on site, but we can meet them at the gate, which is what we do with the pizza guys, where we drive outside of like the barricade, which is basically, it looks just like the Fort Jackson barricade.
Yep.
It's just like it's like a pay booth. You just like drive out, and there's like a little U-turn spot in the front, a little parking lot where all like the sheriffs park, and you like pull out there and you like hand them money, and they hand you pizza, and you're like, that's goods, and you like put it in your car, and then they immediately search your car.
Right?
Centera immediately searches your car.
Yeah. They find the bomb that you just picked up with the pizza.
Yeah, or all the one of the pizza boxes just has a bunch of USB drives in it.
Yeah, we're gonna have to confiscate this pepperoni.
Like base where they bring out food and everyone participates in them because like there are no food options that are good. We got like 1,000 people working in the building. There's no cafeteria.
That's amazing.
We have one cafeteria on site for all 14,000 employees.
Yeah, that ain't gonna do that.
But no one goes to it because it's in the middle of site, and site is 310 square miles.
Yeah.
So
that's a small detail.
it takes
I'm just gonna run down to Charleston Village.
Yeah. So there are people that commute from Charleston and Statesboro.
Oh god.
It's like 80 miles that they drive.
Yes, sir.
But they only do it like 4 times a week.
My longest commute in my life was 45 miles. I'll never do it again.
Mine was from Columbia. I used to live on King Street behind 5 Points, and I would drive to Savannah River and back. It was an hour and a half both ways.
Yep.
That was fun.
Yep.
That was when I stopped working here and started working there, but hadn't moved there yet. So that was only like 4 months or so. It wasn't that bad. Honestly, it wasn't. But yeah, so currently where I live, it takes me longer to get from the gate to my office than it takes for me to get from my house to the gate.
Yeah.
So it takes me about 15 minutes to get to the gate, and then it takes me like 20 minutes to get to my job site. And then it takes me like another 10 minutes to walk to the gate, to like the next gate, because you have to like park your car out in the parking lot, and you have to like walk this like half-mile long.
And do you just give up the time between, like, are you paid from the gate in, or do you just give up that time?
Should I tell you what we say is you're supposed to do, or what I do?
I want to know what you do. I don't give a damn what you're supposed to
From
do.
the second I cross like onto site property, like I'm on the clock, baby.
Yeah. Okay.
Like the second my car passes through, I already work 4 times more than everyone else there, which is like 4 hours a day. So, so like I consider that I'm already working way more. So if I like only worked 9 of my 10-hour days because of the rest is commute time from my like office to car to off site.
Look, man, I'm just saying, if I've got a backpack into my office, when I get to the mountain, I'm at work.
Yeah.
Okay. Well, thank you very much for a very interesting presentation that I had no idea we were going to have.
No problem.
Go team. Right, go team. Thank you, all of you, for coming. It was very good to see you. Our dedicated core of ColaSec family. And yeah, I guess maybe we'll see you guys in December and have a chili cook-off.
Actually, I might. Might be easy.
Who knows? And if you're online, thank you for attending. But this is the end. Good night.